Solve quadratic equations by completing the square. Solving a quadratic equation by completing the square, where a is equal to 1, and the coefficient of x squared is 1. Here we have x squared minus 2x minus 10 is equal to 0. First, we need to complete the square. To complete the square, we take a look at the coefficient of x, which is in this case negative 2, and we divide it by 2, or you multiply it by 1/2, and then you square the whole product here. So you always divide by 2 and you always square it. In this case, we get negative 2 over 2 would be equal to negative 1. When you square that, you get 1. This is a magic number you need to complete the square. If I add 1 to these two terms, I can complete the square. So in this case, I'm going to move the negative 10 to the other side of the equation, or add 10 to both sides of the equation. So I'm going to complete the square between these two terms, which contains the variable x. So we find that to complete the square, we need to add 1 to these two terms. I'm going to add 1 to the left-hand side of the equation. When I add to one side of the equation, I also have to add to the other side of the equation to not change the original equation. So really, I'm adding 0 to this equation. On the left-hand side, not only this would be factorable, also would be completely squared. So let's take a look. You recall, to factor that binomials, I can open two parentheses, x squared, that give me x and x. For 1, I have 1 and 1. And if both of these are minus, I get 1x, and here I have another 1x. Both are negative x and negative x. That adds up to minus 2x. So not only this would be factorable, also would be completely squared. We get x minus 1 squared. So here we completed the square by adding 1. Once again, we find this 1 by taking the coefficient of x, dividing this by 2, or multiplying it by 1/2, and then we have to square that whole thing to obtain this result. So here we get x minus 1 squared is equal to 11. We can use the square root property now. We can say either x minus 1 is equal to radical 11, or x minus 1 is equal to minus radical 11. Once again, recall, if I have x squared is equal to any number like k, x would be equal to square root of k, or x would be equal to minus square root of k. So in this case, my x is expression x minus 1. So we write x minus 1 is equal to square root of 11, or x minus 1 is equal to minus square root of 11. To solve for x, we just simply add 1 to both sides of the equation. So we get our solutions to be 1 plus or minus radical 11. You can write it separately, or you can write it as a combined answer like this. Completing the square to solve ax squared plus bx plus c is equal to 0, where a is not 0. Step number 1, be sure the second degree term has the coefficient of 1. This method only works when the coefficient of x squared or a is equal to 1. If the coefficient of the second degree term is 1, go to step 2, which is the step here. If it's not, if it is not 1, but some other non-zero number a, divide each side of the equation by a. So in order to eliminate this coefficient, if it's other than 1, we just simply divide each term by that coefficient. So if I have 2x squared, then I just divide each term by 2, then I would force to have a coefficient of 1 for the leading coefficient x squared. Step number 2 is to write the equation in correct form. Make sure that all variable terms are on one side of the equation. or the equality symbol, and the constant term is on the other side. You don't really need the constant term to complete the square. Step number 3, complete the square. Take half the coefficient of the first degree term and square it. So you take the coefficient of x, divide it by 2, and you square it, or you multiply by 1/2 and square it. Add the square to each side of the equation. You need to add it to both sides to not change the original equation. Factor the variable side, which should be perfect square trinomial, as the square of the binomial. Combine term on the other side. And step number 4, solve the equation using the square root property. So let's take a look at some examples here. Here we have x squared plus 3x minus 1 is equal to 0. You notice that the coefficient of x squared is equal to 1. I don't need the constant here to complete the square, so I'm going to add 1 to both sides of the equation, write them in the form where all the variables in one side of the equation and the constant on the other side of the equation. To complete the square, I need to take the coefficient of x, which is 3, and multiply by 1/2, or divide it by 2, and then square them. So 1/2 times 3 squared, that give me 3/2 squared, which is equal to 9/4. This is the number I need to complete the square. I'm going to add this number to both sides of the equation. I'm adding to both sides of the equation to not change the original equation. Really, I'm adding 0 to this equation. You could add 9/4 and subtract 9/4 to one side of the equation, like you're adding 0. So, or you're saying that you're adding 9/4 to both sides of the equation. So on the left-hand side, not only this trinomial would be factorable, also would be perfectly squared. So if I were going to factor this, I would open 2 parentheses like that. For x squared, I would put x and x. For 9/4, if I put 3/2 and 3/2 here, and if both of these are plus, you notice that if I multiply the first 2 terms together, I have x squared. When I multiply the last 2 terms together, I will get 9/4. Now look what happens when I multiply the 2 closest term and 2 furthest term. I get 3/2 x, also have 3/2 x. Now these two are going to add up to the middle term, which is 3x. 3/2 plus 3/2, I would add up to 6/2, which is equal to 3. So I complete the square. This is x plus 3/2 squared by adding this number to both sides of the equation. Once again, I found this number here by taking the coefficient of x, multiplied by 1/2, and square them. I get 9/4. And this method only works when the coefficient of x squared is equal to 1. So here I have the form where I can apply the square root property to solve for x. Recall, if x squared is equal to k, x would be equal to square root of k, or x would be equal to minus square root of k. So in this case, your x is this expression, x plus 3/2. So you would write x plus 3/2 is equal to square root of, this is your k, 13/4, or x plus 3/2 is equal to minus square root of 13/4. To solve for x, I can subtract 3/2 from both sides of the equation, and then I would get x equal to minus 3 plus radical 3/2, or minus 3 minus the square of 3/2. So in this case, I would get x is equal to minus 3/2. If I subtract 3/2 from both sides of the equation, plus square root of 13/4. From here, I get that. And here, to combine these, I have square root of 4 here too. To combine these, I'm just separating square root of 13/4 to square root of 13 over square root of 4. We get x equal to minus 3/2 plus square root of 13 over 2. And as you see, I would get x would be equal to minus 3 plus square root of 13 over 2. And same calculations here, you get minus 3 minus square root of 13 over 2. So this would be my solution set. Let's take a look at this example. Solve 3x squared plus 6x minus 2 is equal to 0. Solving a quadratic equation by completing square where a is not 1. So this time the coefficient of x squared is not 1, and in order to follow the method we need to divide each term by this coefficient 3 to obtain 1 as that coefficient. So if I divide each term by 3, I would get x squared here. Here I get 6 over 3, that give me 2. Minus 2 over 3, I would get minus 2/3 equal to 0. To complete the square, I don't need this minus 2/3. I'm going to add 2/3 to both of the equation so I can perform the method on these two terms. Now the coefficient of x squared is equal to 1. Now I take the coefficient of x, which is 2, dividing this by 2 or multiplying by 1/2, and you square them. 1/2 times 2 is equal to 1. 1 squared would equal to 1. So this is the number I need to add to these two terms to complete the square. To not change the original equation, I'm going to add 1 to both sides of the equation. So on the left-hand side, not only this would be factorable, also would be perfectly squared. If I would factor this left-hand side, I would see I get x and x here, and here I get 1 and 1. You see clearly you get x plus 1 squared. You get completely squared binomial here. Now on the right hand side I get 2/3 plus 1. I can write 1 as 3 over 3. So I have the same LCD. So I get 5/3. So now I can perform the square root property. Because if I have x squared is equal to k, from here I conclude that x is equal to square root of k, or x is equal to minus square root of k. My x here is this expression, x plus 1. So you write x plus 1 is equal to square root of 5/3, or x plus 1 is equal to minus square root of 5/3. To simplify that, we just subtract 1 from both sides of the equation to isolate x. So x would be minus 1 plus square root of 5 over 3. Now we need to simplify that. Square root of 5 over 3, it's not reducible, so I can write this as square root of 5 over square root of 3. I cannot have square root at the bottom of the fraction. Anybody remember how to rationalize this? For those of you watching this live, do you remember how to rationalize square root of 5 over square root of 3? What do we have to do? We have to multiply top and bottom of the fraction by, anybody remember that? We need to review that lecture on the square root. Here we multiplied by square root of 3 over square root of 3 in order to eliminate that radical at the bottom of the fraction. So here I would get square root of 9. At the top of the fraction I get square root of 15. So this would be equal to square root of 15 over 3. And that's why we have square root of 15 over 3 here. Similar calculation here with the minus. We would get minus 3 minus square root of 15 over 3 if I combine these two. You'll notice that negative 1 can be written as 3 over 3 to obtain this result. So in place of negative 1, you can put 3 over 3. So here we get negative 3 over 3 plus square root of 15 over 3. So the LCD is 3. Now I can get negative 3 plus radical 15 over 3. Or x equal to negative 3 minus radical 15 over 3.